Hey everyone, this is hopefully going to be one of many CAD tutorial videos that I'll be probably making in the near future for a robotics team. And so I think this is just coming off of last year where some of our CAD lessons were a little confusing and the pacing was either a little too fast or a little too slow. And hopefully these videos will be helpful in some of our onboarding to get everyone on track and familiarized with our CAD software, which is Onshape. And so this first video, I think we can probably, or this first part of this video, we can go through a little bit of the basics of the UI, you would say, I guess, of the when you open up a file in Onshape. And so after creating an account through your school email, you can make an educational account and use Hotchkiss as your educational um, um, institution. But after you start a new file, you'll be greeted with this. You always have a part studio in the bottom corner and assembly right next to it. And essentially, the part studios are where you get started to make your individual parts. And we'll talk through what assemblies mean later. But in terms of basic UI, over here we have our history. I like to call it this sort of feature history because you can look back once you start CADing and sketching. You'll be able to backtrack your steps on how you made the part you made. On right here on the top, I'm just sort of like highlighting this with my cursor right here. These are the sort of planes that we have access to. So we have the top plane, the front plane, the right plane, and the origin here is literally the dot right in the middle. And so planes are sort of the first building blocks of any of the parts that you're going to be CADing, because you're going to always start a sketch on a certain plane. And so to be fair, it doesn't really matter which plane you start a part in. At the end of the day, you'll be able to reorient and rotate your part when you're sort of putting it together with other parts in an assembly. And again, that comes a little later. But here we have, like personally, I really like to use the top plane as my sort of starting point, just because everything is going to face upwards and after I CAD it. And so that's why I use the top plane. And so what you can do here is you can deselect your front or your right plane, or depending on your preference, deselect the other planes. And this simply just helps to clear things up. And so now you only have one plane. The next part of the user interface is right here, which Mr. Boone really likes to call the cube because it is a cube. And so essentially on these corners of the cube, as well as the faces, will help you reorient your sort of perspective on the CAD model. And I recommend you to use a mouse when CADing, just because if you're moving left and right, not rotating and switching your perspective like this and moving left and right in the parts, I would strongly recommend using the mouse. And that would be your center mouse button. And so that is really the basic UI you need. We will go through things like the measure, which is down here in a little bit. But essentially, this is all you really need to know to get started with a sketch. And so to get started with a sketch, you see the sketch button on top. And so sketches are the sort of fundamental building blocks of any of your parts. Everything will have to start from a sketch. And so when you first press the sketch button, it'll pop up with this window and it'll ask you to select the sketch plane right over here. It asks you to select the sketch plane. And so right here, I have the top selected. So I'm just going to click it once, and there it is. Right on the sketch plane, it says that the top plane is now selected. And you can see that this top bar on top has completely changed. We exit out of the sketch. We have these other functions. But when we enter the sketch, we see all these different functions. And so these are very similar to things you find on things like Adobe Illustrator or other drawing tools, the two-dimensional drawing tool. And so right over here, you have your sort of really basic shapes. First, you have your line, very arbitrary. Then you have your rectangle. And so for two different reasons, there are two different tools on the rectangle: the corner rectangle, which you can see here, and the center point rectangle, something like this. And the center point rectangle and the corner rectangle are both useful in their own ways, and you soon figure, which one is more useful. Personally, if you need something to be centered, or the rectangle to be centered, the center point rectangle is always going to be more useful. If you need instead to start from a corner, then the corner rectangle is for you. Sorry, this is not the corner rectangle. Here's the corner rectangle. So don't worry about the other tool, which is the align rectangle. I never really use it, and I don't think anyone else on the team really uses it. Next is their center point circle. Of course, there's other options with the ellipse and all these other things. First, start off with a circle. Of course, it's as simple as it gets. You click on a certain point and drag out to increase the diameter. And your other things like your curves, your 3-point arcs, you select 2 points and you drag your mouse to make this arc, depending on whatever radius you want. Sorry, there's a lot of different things on the screen right now. And next, we have our polygons, which are sort of like, if you need a hexagon, for example, that's going to be a very common shape you need. For example, for your nuts, the hex nuts that we're going to be using in the robotics team. So here, you can see that you select the center point and you drag outwards to increase the size. And here you go up and down the scroll wheel to select how many vertex or how many sides you want in your polygon. In this case, 6 for the hexagon. Your spline is useful when creating very organic parts. You select different points and it creates a curve. And you can press escape to exit out of the curve, and you can manipulate all of these different joints for curvature and for position. And so just of course, that's just sort of a basic introduction to all the regular, arbitrary 2D shapes like we have. But say we create another, like just some random shape here. We made a rectangle. The point is when you start with a shape in your sketch, you're able to extrude it, or it's the most fundamental way to bring a 2D sketch into the 3D world. It's the most fundamental way to bring a 2D sketch into the 3D world. And so this rectangle, I'm selecting the sketch by clicking on this on the feature bar right here, and pressing this extrude button on top of the function will allow me to extrude it. And there's a bunch of settings that we'll go through in a little bit that enable you to customize your extrude. So this is the very first, most basic way to make a 3D shape, is to make a simple sketch and to extrude it. So I think something maybe good that you could practice right now is to sketch a rectangle by selecting a plane, getting used to the UI and using the square, and extruding it to something like looks like this, a really simple thing. And you can probably pause the video to do that if you want. But up next, I wanted to go through constraints, because this is really what defines your sketch and dimension that adds dimension to your sketch. And so depending on your preference technically, but I like to use inches, you can go to this three-line symbol over here, and you can go all the way here to workspace units. And this is pretty important because this sets the preferred length and angle units that you really want. We won't really be using grams because that's sort of for different engineering analyses. But what we're going to really worry about is the millimeters and the angles, or the length and the angle, sorry. I love using millimeter. That's what most people use on the robotics team. It's the most self-explanatory. And to me, I just like the metric system. And you really only need two decimal places worth of, I guess, accuracy. And so this is the setting that I recommend you adopt. And this should be the default, but if it's not, you should set it this way. So that just as a reminder, this goes right here, the 3-bar menu, workspace units, and you can adjust it there. The reason why I talk to you about that is because within your sketches, you're going to need to dimension your, you're going to have to constrain your sketch. And what I mean by constrain is actually adding the dimensions, the relationships between different shapes, and the such. So this is the sort of the constraint bar. which has all your different functions, and it might look a little intimidating at first. But let's first start with the very simple and humble dimension tool. And so once you click on the tool, it will ask for you to click a line or a point or two different points. For example, one, I can click this line and it creates a dimension for you. And here it allows you to change it, the dimension in millimeters. So let's say I want to do 80. And so that it adds a constraint to it. This line is now only allowed to be 80. And that's why you see these lines have turned black. These lines are now a set length apart. And that's why they are called sort of fixed in place. And so that anyways, if you see black, that is a good thing. It means that you have constrained something. Another thing you can do instead of clicking a line is clicking between 2 points or lines. For example, I'm going to click this line and this line below. And this allows me to change the length of the rectangle horizontally. And so I'm going to put this as 40. And so now we have a perfectly dimensioned rectangle. And so essentially the middle of the rectangle, because I use a center point rectangle, is coincident, or right here, it's coincident, which means it is connected. It is connected to the origin right here. It is connected to the origin. So the rectangle's position is fixed. And we added dimensions to both sides of the rectangle, which fixes the length. So essentially everything is turned black because it is completely fixed. It is completely dimensioned and it is completely constrained. And so you will have to be using the dimension tool very often for this exact reason, for making dimensions very precise. And so, yeah, that is the most basic restraint tool, constraints tool, and it is the dimension tool. And there are other things that you can use with the dimension tool, mainly angles. So right here, we have a very arbitrary line. Again, let's do this again. Let's make this 70 millimeters long. And if you select between 2 points that are not parallel, for example, it gives you, and connecting, sorry, see the lines are connecting right here. If you select between these two lines like this, it'll give you an angle. And so I want, say, 45 degrees. And there we go. Once again, everything is completely black because it is all constrained to these dimensions. So I wanted to do a more with the dimension tool. How about you? I guess there's one more thing with circles. Instead of a length, of course, you have your diameter. In this case, it's 50, so we can change that. And now it's constrained. There we go. And again, the center, the circle starts with it's a center point circle. And so I have aligned it with the origin of our of the drawing surface. And thus it is now fixed. The position of the circle is fixed because it is coincident with the origin. So how about we change that as an activity, change that original rectangle and use the dimension tool and practice with the dimension tool to make your rectangle completely constrained. So something that looks like this. And you can pause the video again to try that out. And add, feel free to mess around with the sketch to add a line and to do an angle dimension. Right over here. Looks something like this. Use an angle dimension. Okay, if you finish doing that, then we can look into some other constraints, really basically, and some of the issues that you may run through when you're CAD, which is when constraints clash. So first of all, I'll actually show you that again. So the rectangle, for example, if I make a rectangle, it'll actually sort of pause, right? And it'll highlight that little box down below with one of the dimensions. If you press enter at this point, it allows you to immediately dimension it. And again, this pops up on the other length, 57.51 right over here. If I press enter again, it creates the dimension for me. So just a very handy shortcut for you. Then after I dimension it, let's say I want to try to move sort of to add a different constraint in. Sometimes you might see a clash. For example, if I want to make a parallel tool or an equal tool, for example, this makes lines equal in length. So if I try to equate this length of the rectangle to this length of the rectangle, everything turns red because, as the pop-up says, the sketch could not be solved because we have two constraints on it. This is already dimensioned as 100 millimeters long. This is 60 millimeters long. And if we try to use this tool, which is the equal tool, which makes lines equal in length, it crashes. Your sketch no longer works because it identifies that there's a discrepancy with your dimensioning. And so when that happens, when you try and do that, just press the Command Z and look over your sketch again and see that if which constraints are clashing. In this case, these are length constraints. So let's run through some of these other constraint tools that are very useful, or at least the ones that I use most often. So first, we have our coincident tool. Simply, this attaches a point to another point. As you can see here, I'm going to select this point right here and select the origin. And the coincident tool allows it to be attached onto the origin. And so the position of the circle is now fixed. For example, if I wanted to dimension this length, in this case it's 40, and change that length, it will clash because it is trying to position itself in the center of the rectangle, but this is trying to push it further away from the line than it's supposed to. And thus, the dimension fails. The sketch cannot be solved. The next tool that we have on the list is concentric. It makes any point coincident with the center of an arc or circle. So for example, I have another circle right here. If we make these two circles concentric, the centers of the circle will match. So kind of like coincident in some aspect, but with a few nuances. It always aligns it to, it's applied to centers and arcs. So here we go, we're going to dimension it. No, maybe we do 40. It looks a little better. Next on line, we have parallel. So for example, if we were to make an arbitrary line right here, we want to make it parallel. Here it is. It's now parallel. A very simple trick. If we don't do the parallel, let's try perpendicular. This is not, we kind of skipped over a few things, but here you go. Now, oh, it probably disappeared. So let's combine some of these. I'm going to make these concentric, and then I'm going to make this perpendicular, sorry. So now it's going to look like this. It's perpendicular to the rectangle. And feel free to mess around with some of these. Some of these are very self-explanatory, like horizontal and vertical. This makes a line either horizontal or vertical, as easy as it sounds. That's a vertical. And now this is completely horizontal. Same thing with the equals we went through just now. It makes two lines two objects equal in size. For example, right over here, we equate these two, and it equates to one or the other. And so you might have to mess around with that. Midpoint is quite useful. For example, when you align a circle to a certain part, or it needs to be right in the middle of something that's symmetrical, you're going to need that. So midpoint, select this little point right here, and select, say, a line. And it puts it right in its midpoint of this line right here. So essentially, you use these constraints to your advantage. I don't think you have to worry about the other constraints like tangent, normal, pierce, symmetric, fix, or curvature. Those are more advanced tools that you won't need to do yet. But essentially, these are your friends. These tools that help you dimension enable you to make more precise shapes, more beautiful parts, and parts that will fit the robot and things like that. So how about we recreate this shape right here using your midpoint, your concentric and coincident points, and utilize your dimension tools to make it look kind of like this, kind of looks like a camera. So maybe if you can do that using your different tools, your different constraint tools, that would be great. Yeah. And so if you finish doing that, let's look back at the extrude let's look back at the extrude tool. So over here, if you can either select the sketch as a whole, or you can select parts of the sketch. For example, I just want to extrude this part, for example, and it extrudes this part. And so as you click into the extrude, you'll have a lot of different options. I mean, your first one, you want to always, I mean, when you're first sort of adding a part or making a part, it's always going to be a new extrude. And so there's a few options. This might be a little confusing. This is called an end type as you hover over it. And so essentially when it says blind, you're just going to be extruding a thing for a certain length. In this case, it's 25 millimeters. And when we do more advanced parts, you see that these other options will start to make sense. But essentially, all you have to know now is to extrude it to certain lengths. For example, 20, you can even go to precise, like 3 millimeters, make a little very thin, I don't know, donut or something. Yeah, essentially that is sort of I hope that's a good introduction to sketching, dimensioning, and very basic extrudes. And so there's a lot more methods to cover that we'll talk about soon. So yeah.